All right, in this video, we are going to graph the tangent function. So here's the equation for the tangent function, and then below are the characteristics. So the length of one revolution between the curves is a period of pi. The domain is all real numbers except for the odd multiples of pi over 2. We're going to have vertical asymptotes at increments of pi over 2. The range of values is all real numbers. Here's those vertical asymptotes at pi over 2's. The x-intercept occurs between each pair of asymptotes. It is an odd function, means it has origin symmetry. So here's what the graph looks like. So I'm just going to focus on one revolution. So if we think back to the unit circle, and here is 0, and then this is pi over 2, and down here is negative pi over 2. How we find the tangent function is by taking the sine value over the cosine value for your ordered pairs. So if we think about 0 radians has the ordered pair 1, 0, and we take the sine, which is 0, and divide it by the cosine, which is 1, we're going to get a value of 0. So when the angle is 0, you're going to have an output for the tangent to be 0. So I just graphed that first ordered pair. Now if we go up to pi over 4, it has the ordered pair square root of 2 over 2, square root of 2 over 2. If you take the sine and divide it by the cosine, so that ordered pair, you're going to get 1. So here is pi over 4. The output is 1. If you do the same thing for negative pi over 4, it has the ordered pair positive square root of 2 over 2, negative square root of 2 over 2. So when you divide those, you're going to get negative 1. So here is negative pi over 4, and you're going to go down 1. What's going to happen is you're going to have what looks like a snake. Now, I'm going to just change colors, getting a lot of colors happening here. Let's go up to pi over 2 here in the purple. It has the order pair over 0, up 1. When I take the sine and I divide it by the cosine, so 1 divided by 0, it's undefined at pi over 2. So that's why we have this vertical asymptote here at pi over 2. If I go down to negative pi over 2, it has the order pair over 0, down 1. If I take my sine and I divide it by my cosine, so negative 1 divided by 0, it's also undefined. So we get another vertical asymptote where it's undefined at x equals negative pi over 2. So what I've graphed is just one revolution between those asymptotes. So this period of this snake, or S, is a distance of pi. What's in the green is one revolution for your tangent function. Now look to the right and the left. What happens is the pattern just continues every pi increment. So that's where you get that period of pi. So this is the graph of the tangent function. So here is just a detail of a set of ordered pairs for x and then the output when you evaluate it for y. And this is just showing you that one revolution graphed out. There are variations to the tangent function. So those would be like your children. So you would want to follow these steps here. And we will do that on another example. Here are the steps that I like to follow, and we will do that on another example. So we will follow these steps to graph if we have a vertical stretch, a horizontal reflection. Notice here, the period is going to be pi over b, not 2 pi over b like we have our sine and cosine function. Then we have a vertical shift that could happen, and our phase shift is going to be where we move those asymptotes.